Let's understand the different networking models available in computer networks. There are majorly two models, which are OSI model and TCP model available. So OSI stands for Open System Interconnection, which is a theoretical model developed to understand the computer network architecture. It has a 7 layers. Data flows from the first physical layer to the seventh application layer. So talking about the physical layer, it contributes to the binary bit transmission, that is zeros and ones. And the components involved are hardware specs, N-cables, NICs, which stand for Network Interface Card. Then the next level is the data link layer, where the frame addressing and error detection happens, where the bits are converted to frames and the error detection algorithms like cyclic redundancy check is applied. Then the next layer is network, which is responsible for the end-to-end connection routing, like where your network call should write. And the protocols used are TCP, UDP, IP, and the VPNs. Next we have is the transport, which takes care of the transmission of bits over the actual physical layer. It also involves the transmission control protocol, NGLAN protocol, and the port numbers. Then we have is the session layer. Session layer is possible for managing the session between the nodes. Like when we are talking about the connection between the two nodes, session is very much important um, to establish the connection, and it should have a certain expiry. Like you cannot let connect the two nodes for eternity. So that's where the session layer uh, plays the role. Then we have is the presentation layer. It involves the data formatting, whichever data is coming from the transport layer. The data comes in either in encoded or in encrypted format. So that data should be decrypted again. That is done in the presentation layer. And the security protocols include SSL or the TLS. SSL stands for Secure Socket Layer and TLS stands for Transport Layer Security. Both are same terminologies, but TLS is the secure version or the higher version of SSL that we used majorly today. And lastly, we have is the application layer, which is the end layer which user sees. It's a user interface, and the network protocols used are HTTP and HTTPS, which are hypertext transfer protocol used to communicate over the World Wide Web. Other protocols used are email and the FTP. Emails include SMTP, like Simple Mail Transfer Protocol, and File Transfer Protocol. The next model we have is the TCP IP model. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. It is a four-layer architecture. It is not. It is a less layered architecture than OSI. Why it contains four? It's because it's a practical implementation. Talking about the layers, first layer consists of the network access layer, which contributes to the physical or hardware addressing. And the technologies involved are Ethernet, Wi-Fi, MAC addressing, and the hardware drivers. If we compare it with the OSI model, the first two layers, data link and the physical layer, together forms this network access layer. We can refer these two for the first layer. Second layer we have is the internet layer, which is responsible for logical addressing, whatever we put on the net that should route to the appropriate IP. And the packetization also happens here. Packetization means whatever data you send, the data should be sent in a chunk format. You cannot send all the data all at once. So the data will get divided into chunks and will be sent over the network. Here, the protocols involved is majorly the IP, Internet Protocol. And as we know, there are two major IPs, IPv4 and IPv6. Then we have is a transport layer. Okay, so if you want to map this internet with OSI layer, we can map it with the network layer. Then we have is the transport layer, which is responsible for the end-to-end communication and the error checking, like cyclic redundancy check. The protocols used are TCP, which guarantees the delivery, and UDP speed. That is the user diagram protocol. So what is the major difference between these two protocols, TCP and UDP? TCP is a lossless protocol, whereas UDP is a lossy protocol, and they have different roles to play. TCP guarantees the delivery. That means whatever data you send, that should be sent securely and completely. Whereas UDP does not guarantee the delivery. The data may lose, but it ensures the speed delivery. The last layer in the TCP model is the application layer, and it contributes like user interface, network services, data formatting, and session control. If you want to map it with the OSI model, the last three layers, okay, transport layer can be mapped to this transport layer of the OSI model, and application layer consists of the remaining layers like session, presentation, and application can be mapped to the application layer. So now the question arises, why there are two models and what is the practical implementations? OSI is a standard model which is a theoretical one. It's not implemented. It's just to study the computer networks and how the architecture behaves. Whereas the TCP/IP is the practical model implemented, and the most common example is our internet, which is a global WANs, worldwide data network.